Hi class, this is Mr. Boovie. We are on example 1 in section 1.1. We are working on understanding domain and range today. This example is not in your student companion white packet, but it is a similar example to the try-its that you'll see on page 2 in that white packet. Between pages 1 and 2, you'll see an empty page called Additional Space for Notes. Feel free to take any notes that you'd like as you're watching this video. You should also have your TI calculator out right now because we're going to practice entering this equation. So here we go. We have y equals x squared minus 3, and we're going to talk about domain and range. We want to find the domain and range. So on your calculator, here's mine. I went to the y equals screen. And in y1, I'm entering x squared minus 3. Keep in mind that when you are putting in minus 3, make sure you're using the subtraction sign and not the negative sign at the bottom. Okay? So let's go ahead and hit zoom 6. That'll give us a standard graphing window. Zoom 6. You can see Z standard. That'll give us a nice graphing window where we will see the graph of x squared minus 3. This shape should look familiar to you from your studies in Algebra 1. This is known as a parabola, of course, since it has x squared. And for the domain, we want to think about how far the graph goes from left to right. We want to think about all the possible x values that we can put into this function, and that will be its domain. Remember, the domain is all of the x's. The range goes along with all of the y values that come out of the function. So if you think about this parabola as it stretches from right to left, it's going to continue to open wider and wider and wider, so any x value is allowed to go in for the domain. Let's keep that in mind. The domain can be any number, any real number you're allowed to put in, square it, and subtract 3, because that was the equation that we're using. If you think of any number in the world, you're allowed to square it and subtract 3. There are no restrictions. Now, the range is a little trickier because, as we see, this U-shaped graph, this parabola, is opening upward, and it's going to hit all of these y values as it grows up, 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 and away, up, 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 and away. But there's an entire family of y's down here that the graph never touches. We could do this. We could hit trace on our calculator. And let's take a look. When you hit trace, it should pop up with x equals 0 and y equals -3 at the bottom. And as you scroll to the right or to the left, you could see those y values going up. They'll go up forever. Or if you go back to the left, they'll still go up forever. But they're never going to reach below this y value right here. So you want to think about what the smallest y value is that this graph touches. And that value is -3. So it's never going to go below a y value of -3. So let's go back to our problem here, and let me click on the solution. There's the graph. Talks a little bit about the domain. You can square any real number, so any number can be the input for x. The set of all possible outputs is known as the range. It looks like here the minimum value is -3. So what we want to do is we want to think about some ways that we can tell the teacher, the reader, whoever is doing this, what the domain and range are. So there are a couple ways to do this. One is known as set builder notation. So let's click on that and see what set builder notation looks like. It uses a verbal description or an inequality to describe the numbers that are allowed. So here is the domain in set builder notation. We read this, the set of all values, x such that x is a real number. No restrictions on x. For the range, though, we're going to use this inequality right here to say that it's all of the y values. This line means such that the y's have to be greater than or equal to -3. So that would be the domain and the range, for example, 1, using set builder notation. Next, we have interval notation. And this is the one that's more popular, and you'll see more as you go through your career here at Mount Lebanon. Interval notation uses either parentheses or brackets to determine what the domain and range are. So in interval notation, here's the domain. The way I would read this is the domain goes from -infinity to +infinity. It contains all of the numbers from -infinity all the way to +infinity with parentheses. In interval notation, let's take a look at the range. Now, note that we have a bracket, and we start with -3. It's telling us to go to infinity. So it looks a little confusing, but we'll see this as the lesson goes on. We start at -3. The bracket means that it's allowed to equal -3. So the greater than or equal to sign always goes with a bracket. Let's say we weren't allowed to include -3. If that was the case, there would be a parentheses here instead of a bracket. So the parentheses goes with greater than or less than. The bracket goes with greater than or equal to or less than or equal to. More about that here when we take a look at comparing notations. Here are some examples. I'm going to leave you with these. So what I'd like you to do is take a few minutes to take a look at this table here. It's showing you what a domain would look like in interval notation on the left, in set notation on the right, and using words in the middle. All right, I'll leave you with that. And when you're finished, when you think you have a good handle on that, I want you to do the try it problems on page 2, at the top of page 2 for example 1. And we'll go over those tomorrow in class.